fair dice are rolled. Find the probability that a sum of numbers is 8, sum of numbers is 6, product of numbers is 36, and both the dice show the number 4. Now, firstly, two fair dice. So, two dice are rolled. Not one, but two are rolled. And we are supposed to find the probability of it. Now, firstly, before finding the probability, let us define the sample space. Now, what will be the sample space? Now, for one dice, there will be numbers from 1 to 6. For the second dice also, the numbers will be from 1 to 6. Correct? So, to find out the total exhaustive events, we are supposed to take that 6. 6 is the number. In dice 1 also you will have 6. In dice 2 also you will have 6. So, 6 is the major number, and to this, what are the number of dice that we are using? So we are rolling 2 dice, so it is 6 square. So 6 square is 36 events. Now if you remember, we had solved this part here. The sample space or in a random experiment of rolling 2 dice. Now, what are the possibilities that we can get when we roll 2 dice? Now, if you see, this is dice number 1 and this is dice number 2. Now, both dice number 1 has the numbers from 1 to 6 and dice number 2 also has number from 1 to 6. And by seeing the combination of all of this, we get 36 possible events. And how do we find out that 36? 6 to the power 2, that is 6 is the number on the dice, and we have 2 dice. So the total outcomes will be 36. Okay, so this will become the exhaustive events, or this will become the exhaustive outcomes for the event. Okay, now coming back to our problem here. So firstly, we have to define the total exhaustive events. Now the sample space will be 1 to 6 because you will only have numbers from 1 to 6. But totally when you take 2 dice, you will have 36 outcomes when they roll the dice any number of time. Did you all understand the first part? Any doubts still here? Now, moving further, let us solve each of the problem one after the other. Now, first question they have asked is, find the probability that sum of numbers is 8. Okay. Now, when they roll 2 dice, when they roll 2 of the dice, now here we are supposed to find the probability of getting the sum as 8. Okay, in which all cases can we get sum as 8? Now let us see, let us take an example. Now first, if dice number 1 and dice number 2, okay, now if the dice is giving 1 here, okay, and the other dice is giving 6, we will get only 7. So we are not getting 8. 1 plus 6 is 7. We are not getting 8. So this is ruled out. We cannot consider this. Okay. Now, next one. If dice 1 is giving 2 and if dice 2 is giving 6, 2 plus 6 is equal to 8. Yes. So this is one of the possibility of getting 8. 2 plus 6. Then if dice 1 is giving 3 and dice 2 is giving 5. 5, 6, 7, 8. Again, we'll get 8. If dice 1 is, when rolled out, will give 4, plus dice 2 also, if it gives 4, then again it is 8. Now, if dice 1 will give 5 and dice 2 will give 3, again it is 8. This also should be considered. It is not like repetition, because here dice 1 was at 3 and dice 2 was at 5. So these two, this one and this event, is a different event. Okay. Next, if dice 1 is giving 6 and if dice 2 is giving 2, this also is 8. Okay, which means you're supposed to get 5 events and not only 4. So lastly, that's all, right? So 6, 1, 7 will happen. So how many events do we have? We have 5 events, not 4, but 5 events. Now this 5 events, out of what is the exhaustive event? Exhaustive outcomes will be 36 outcomes. Out of that, these 5 are these 5 are favorable to us. Understood? So the probability of A, that is the first event. What is the A event? Event is sum of getting the numbers, which is 8. So we have 5 events or 5 outcomes out of 36 outcomes where we are getting the total as 8. Did you all understand? Yes or no? Okay. Next. Now that was your first one. Now this can be asked for your 14 marks questions. Okay. Now the second one. This is 5. I will correct and send it. Then the second question. Sum of the numbers is 6. Now first we found out sum of the number is 8. Now second event, that is event B, is sum of the numbers is 6. Now let us again take dice 1, dice 2. If it is 1 plus 5, you will get 6. Correct? 3 plus 3 will be 6. 2 plus 4 will be 6. Then again 4 plus 2 will be 6. Then 5 plus 1 will again be 6. Anything else? 5, 4, 3, 2, 1. 6 we cannot consider. Right? So if dice, when I roll 2 dice, what is that result if I get? Where I add both the results of the dice, I should get the 6 number. So if dice 1 is giving me 1 as the answer, and if dice 2 is giving me 5 as the answer, then I will get, when I add both of them, I will get 6. Similarly, 3 plus 3, 2 plus 4, 4 plus 2, 5 plus 1. Okay. So what are the favorable outcomes for me? Wherever I get 6, I have 5 favorable outcomes, where out of 5 favorable outcomes, the total number of outcomes is 36. Out of that, 5 outcomes are favorable to me. What is that favorable? Where I get the sum as 6. Are you all able to follow? Yes or no? Are you all able to follow or not? Okay. So first one we got the sum as 6. Second one we got the first one we got sum as 8. Second one we got sum as 6. Okay. So these are the first two questions. Now going on to the third one, product of the numbers is 36. Now if dice 1 gives a number and dice 2 gives a number, when we multiply them, the answer should be 36. Okay, let us check with every number. 6, 1, we won't get 36. Okay, ruled out. Then 5, 2, this is 6 ones are 6. 5 twos are 10, ruled out. Then 4 into 3, 4 threes are 12. Then 3 into 4 is also 12. 2 into 5 is again 10. 1 into 6 is 6. Another possibility, 5 into 5, 25. 4, 4, 16. 2 and 3 will not come. 6 into 6, 6 6 are 36. Correct? 6 6 are 36. So only one outcome is favorable to me, where I will get the product of the numbers as 36. When I roll 2 dice and both the dice is giving me 6 as the answer. If dice 1 is also giving 6 as the answer, and if dice 2 also is giving me 6 as the answer, only in this one case I will get the multiplication of them as 36. Okay, so there is only one favorable event out of total 36 events where I will get the product of the numbers as 36. Understood? Understood the third one? Understood or not? Okay. Now, finally, the last one. Both the dice should show the number 4. So dice 1 also should show the number 4, and dice 2 also should show the number 4, and this will be only one case, because dice 1 has only 1 4 and dice 2 also has only 1 4, right? So this is only one. I can expect only one favorable event out of total 36 exhaustive events, where we will get 4, both the dice being 4. Okay, so the probability again will become 1 by 36, which is 0.02778. Understood? Any doubts in this problem? Any part of it you want me to repeat it again? Now, next problem. Now we will be using some additional theorem and all that. Okay. So let us see. A dice, this is again dice. A dice is thrown once. Okay, a dice is thrown once. So what is the probability of getting 3 or 5? So what is the probability of getting 3 or 5? So firstly, before we get into the problem, let us define the sample space. So what is the sample space? Since it is a dice, the numbers will be from 1 to 6 and this will be the sample space. If the dice is only 1, 6 to the power 1, which will be 6. If there are 2 dice which we are using, 6 to the power 2, so we'll have 36 outcomes. So these are the number of outcomes. For 1 dice, it will be only 6 outcomes. For 2 dice, it will be 36 outcomes. For 3 dice, you'll have to power it to 3. Okay, so since it is only 1 dice, we have only 6 outcomes. Total number of outcomes will be only 6. Okay, now let us read the question here. A dice is thrown once. What is the probability of getting 3 or 5? Now in this problem, they say or. Okay, so we will be using the additional theorem here to solve such problems. How do you identify to use additional theorem? These words in the question: or, odd or multiple, multiple of 2 or 3. Okay, so that is how you recognize that we have to use a different form or different method to solve the problem. Fine. Now, let us define the events. Let A be the event of getting 3 and B be the event of getting 5. So, if you take the first one, they're saying that we have thrown the dice once. So, what is the probability of getting 3? And what is the probability, or what is the probability of getting 5? Okay, so that is the first part. Let A be the event, capital A be the event of getting 3 or capital B be the event of getting 5. Okay, now let us solve this. So we are considering capital A as 3. So I hope you know the set. So set A will have only one element, which is 3, and set B will have only one element, which is 5. Because we are expecting that outcome from 1 to 6 numbers, we are expecting an outcome of 3 for A. Excuse me. And we are expecting an outcome of 5 for B. Okay, now one more thing which you'll have to understand is, since it says or 3 or 5, which means if 3 is the answer cannot be 5. If 5 is the answer cannot be 3. So these are exclusive events. Okay, which means if one is accepted, the other is rejected. Okay, if 3 is accepted, 5 is rejected. If 5 is accepted, 3 is rejected. Okay, so it means that there is no common thing between 3 and 5. They are exclusive events. How did we know it is an exclusive event? Because the question says or. Either it can be 3 or it can be 5. Concentrate well. Such problems can be asked. Okay, the problem will look easy, the solution will look easy, but you have to understand the logic to solve it. Okay, so the answer can be 3 or it can be 5. So if the answer is 3, it cannot be 5. If the answer is 5, it cannot be 3. They are exclusive events. They exclude one another. Okay, so there is nothing in common. So A intersection B, I already told you, you will check what is common and then you will consider that. Now, since nothing is common, it is a null set. Null set or empty set, which means there is no elements in that set. Okay. Now, probability of getting 3 or 5 is equal to P of A union B. This is the additional theorem. P of A union B is equal to P of A plus P of B minus P of A intersection B. Again, we have learnt additional theorem formulas for exclusive and non-exclusive events. Let us go back and check once again. I know many of you would have forgotten also. Let A and B be two events with respective probabilities P of A and P of B. Then the probability of occurrence of at least one of those events, at least 3 or 5. I at least want 3. If I'm not getting 3, I at least want 5. I at least want one of the answer here. Okay. So in that case, we will use this formula P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay. So since this is a exclusive event, so we will be taking this A intersection B as 0. This part we will take it as 0. Okay. And we'll find the answer for the rest of the part. Now, P of A union B is equal to P of A. P of A means what is the probability of getting 3? What is the probability of getting 3? If I roll dice once, I can get 3 only once because I am rolling the dice only once, right? So the probability of getting 3 is only once out of 6 numbers. Similarly, probability of getting 5 is also only once out of 6 numbers. Correct? So 1 by 6 plus 1 by 5. So P of A is 1 by 6 plus P of B is 1 by 6 again minus P of A intersection B. Now, since there is no common, this will become 0. Okay. Now, find the LCM. 6 is common. So, 1 plus 1 is 2. So, the probability of getting 3 or 5 is 2 by 6 or 0.33. Did you all understand? You just have to be careful in considering the possibilities and read the question very, very carefully more number of times. Once you read the question and process the question, only then you'll be able to understand. Can we go to the second question? No doubts in the first one? Now the second question is multiple of 2 or 3. Now let us read the question again. A dice is thrown once. What is the probability of getting multiple of 2 or 3? Now what are multiple of 2 or 3? 2 ones are 2, 2 twos are 4, 2 threes are 6. There are only 6 numbers. So I can only get until 6. Now, what are the multiples of 3? 3 ones are 3, 3 twos are 6. 3 threes are 9, they cannot get because the numbers are only till 6. Okay, so first we will define what are the events. So let C be the event of getting multiple of 2. So C is the event of getting multiple of 2 and D be the event of getting multiple of 3. Okay. So multiple of 2, 2 ones are 2, 2 twos are 4, 2 threes are 6. Correct? And multiple of 3, 3 ones are 3, 3 twos are 6. Now, do you find any number common between this C and D? So if you see, 6 is common, correct? 6 is common between C and D. So I will take that as intersection. Always remember, intersection means common element. Okay, so since 6 is common, I'm going to take that here 6 as C intersection D. Okay, now use the same formula again, but instead of A and B, use C and D. Okay, probability of getting a multiple of 2 or 3. Since they have given or, we are doing so much exercise. Okay, so multiple of 2 or 3 is nothing but P of C union D is equal to P of C. C is the event of getting multiple of 2. D is the event of getting multiple of 3. So how many outcomes are there in C? There are 3 outcomes. And there are 2 outcomes in D. So out of totally 6 outcomes, C has 3 favorable outcomes and D has 2 favorable outcomes. And if you take the common element, there is only one outcome. Don't take it as 6. Count the number 1, 2, 3 like that. Okay, 1, 2, 1. So minus 1 by 6. So 3 by 6 plus 2 by 6 minus 1 by 6. Take LCM as 6. 3 plus 2 minus 1. 3 plus 2 is 5. 5 minus 1 is 4. So 4 by 6 will be the probability of getting either 2 or 3. In decimal, you can write it as 0.6667. This is the answer for the second one. Any doubts in this? Did you all understand first of all? Yes or no? Okay. Now let us go to the third question. Now the next question, again we'll have to read the question again. Now the next one is, a dice is thrown once. What is the probability of getting odd or multiple of 3? Okay, odd or multiple of 3. Odd numbers or multiple of 3. That is what is the question. Either you get odd numbers. What are the odd numbers? 1, 3, 5 can be the odd numbers. So this is one event. Let us name this event as E. Or you will get again multiple of 3. So what is multiple of 3? 3 ones are 3, 3 twos are 6. So let us name this as event E. This is supposed to be F. They have written it as D again. Okay, wait a second. Okay, fine. Now the event D was also multiple of 3. So we are continuing that. in this problem, event C was getting multiple of 2, event D was getting multiple of 3. Correct? So I am taking the same D event here, multiple of 3. Okay. So we have 3 outcomes for event E and we have 2 outcomes for event D. Now check if there is any common number between E and D. So E intersection D, which is a common element. So if you see, there is 3 which is common between E and D. So 3 is present in odd number, 3 is present in multiple of 3 also. So 3 is the common number and there is only one outcome which is common. There are 3 outcomes which is common for odd numbers, 2 outcomes which are common for multiple of 3 and 1 outcome which is there for common element, that is E intersection D. Now just put that into the formula. So probability of getting a odd number, that is event E, is 3 favorable outcomes out of total 6 plus probability of getting multiple of 3, which is D, outcome D, that is 2 possible outcomes out of 6 minus what is common? 3 is common. So only one outcome. So 1 divided by 6. Again 3 plus 2 minus 1 will give you 4 by 6. Understood? Third one. Any doubts in this? Now, going on to the fourth one. Let's read the question once again. A dice is thrown once. What is the probability of getting odd or even number? Now, E, we have already defined event E as getting an odd number. So, let us take event F as getting a even number. Okay. E is an odd number and F is a even number. Now, let us write. So E is an event of getting odd number. So what are the odd numbers I can get? 1, 3, 5. That's all. I cannot go more. 7 and all I cannot get because the dice will only have 6 numbers. Then F is an event of getting even numbers. So what are the even numbers? 2, 4, 6. These are the even numbers I can get. Now, can you see any common in these two numbers? 1, 3, 5, 2, 4, 6. There is nothing common. Okay. So, E intersection F is empty set or it is called as null set. Okay. Since there is nothing common, we give it as empty set or null set. Now, put this values in the formula. How many outcomes are there for E? 3 outcomes. 1, 3, 5, right? So 1, 1 and 1. There are 3 outcomes. Again for F also there are 3 outcomes. And for E intersection F there are 0 outcomes. So 3 outcomes out of 6 outcomes. 6 is the total number. So out of 6, for me what is favorable is 3. And then plus again 3 out of 6 minus 0. So 3 plus 3 is 6 out of 6. So therefore the probability of getting an odd or an even is 1. Okay, you might get an odd number or an even number. Clear? Any doubts? Everybody understood this problem? But be careful in solving such problems. First, read the question, analyze the question. If it is or which is given, what are they asking, how many times the dice is thrown, all that you have to understand and only solve it. Clear? Understood, right? Any doubts in this? Any part of the problem you want me to repeat it again? Okay, such problems can be asked for 14 marks. What we are solving now, these problems are usually asked for 14 marks, sometimes for 6 marks also. They will give you a little easier and problem and ask for 6 marks. Yeah. So that's it for today.